In Unix computing, the system load is a measure of the amount of computational work that a computer system performs. The load average represents the average system load over a period of time. It conventionally appears in the form of three numbers which represent the system load during the last 1, 5, and 15-minute periods. Unix-style load calculation: all Unix and Unix-like systems generate a metric of three load average numbers in the kernel. Users can easily query the current result from a Unix shell by running the uptime command. $uptime, 1434 on 3 seconds up 1043, for users, load average, 0.06, 0.11, 0.09. The W and top commands show the same three load average numbers, as do a range of graphical user interface utilities. In Linux, they can also be accessed by reading the loadav file. An idle computer has a load number of 0. Each process using or waiting for CPU increments the load number by 1. Most Unix systems count only processes in the running or runnable states. However, Linux also includes processes in uninterruptible sleep states, which can lead to markedly different results if many processes remain blocked in I/O due to a busy or stalled I/O system. This, for example, includes processes blocking due to an NFS server failure or to slow media. Such circumstances can result in an elevated load average, which does not reflect an actual increase in CPU use. Systems calculate the load average as the exponentially damped weighted moving average of the load number. The three values of load average refer to the past 1, 5, and 15 minutes of system operation. For single CPU systems that are CPU-bound, one can think of load average as a percentage of system utilization during the respective time period. For systems with multiple CPUs, one must divide the number by the number of processes in order to get a comparable percentage. For example, one can interpret a load average of 1.730.607.98 on a single CPU system as, during the last minute, the system was overloaded by 73% on average. During the last 5 minutes, the CPU was idling 40% of the time on average. During the last 15 minutes, the system was overloaded 698% on average. This means that this system could have handled all of the work scheduled for the last minute if it were 1.73 times as fast. In a system with 4 CPUs, a load average of 3.73 would indicate that there were, on average, 3.73 processes ready to run, and each one could be scheduled into a CPU. On modern Unix systems, the treatment of threading with respect to load averages varies. Some systems treat threads as processes for the purposes of load average calculation. Each thread waiting to run will add 1 to the load. However, other systems, especially systems implementing so-called M-N threading, use different strategies, such as counting the process exactly once for the purpose of load, or counting only threads currently exposed by user thread scheduler to the kernel, which may depend on the level of concurrency set on the process. Linux appears to count each thread separately as adding 1 to the load. CPU load versus CPU utilization, the comparative study of different load indices carried out by Ferrari al. reported that CPU load information based upon the CPU queue length does much better in load balancing compared to CPU utilization. The reason CPU queue length did better is probably because when a host is heavily loaded, its CPU utilization is likely to be close to 100% and it is unable to reflect the exact load level of the utilization. In contrast, CPU queue lengths can directly reflect the amount of load on a CPU. As an example, two systems, one with 3 and the other with 6 processes in the queue, are both very likely to have utilizations close to 100%, although they obviously differ. Reckoning CPU load: on Linux systems, the load average is not calculated on each clock tick, but driven by a variable value that is based on the Hertz frequency setting and tested on each clock tick. Although the Hertz value can be configured in some versions of the kernel, it is normally set to 100. The calculation code uses the Hertz value to determine the CPU load calculation frequency. Specifically, The timer ccalc load function will run the algorithm every 5 Hz, or roughly every 5 seconds. Following is that function in its entirety. The countdown is over a load FREQ of 5 Hz. The AVE-run array contains 1 minute, 5 minute and 15 minute average. The CALC load macro and its associated values are defined in SCHEDH. Other system performance commands. Other commands for assessing system performance include, uptime, the system reliability and load average, top for an overall system view, VMSTAT. VMSTAT reports information about runnable or blocked processes, memory, paging, block I/O, traps, and CPU. HTOP Interactive Process Viewer, DSTAT, 1, helps correlate all existing resource data for processes, memory, paging, block I/O, traps, and CPU activity. IFTRP Interactive Network Traffic Viewer Per Interface, NTHOGS Interactive Network Traffic Viewer Per Process, IOTOP Interactive I/O Viewer, IOTOP Homepage, IOSTAT for Storage I/O Statistics, NetStat for Network Statistics, MPSTAT for CPU Statistics, TLOAD Load Average Graph for Terminal, XLOAD Load Average Graph for X, LOADAVE text file containing load average. See also, CPU usage. External links, Neil J. Gunter. Unix Load Average Part 1, How it Works. TeamQuest. Retrieved August 12, 2009. Andrea Lewis. Understanding Linux CPU Load, When Should You Be Worried? Retrieved July 21, 2011. Explanation using an illustrated traffic analogy. Ray Walker. Examining Load Average. Linux Journal. Retrieved July 21, 2011. Carson Becker. Linux OSS Load Monitoring Toolset. LoadAVG. Notes, this paper's discussion is useful, but it contains at least one error. In equation 3, the equation should be load, T, equals NA 5/60 plus load, T1, instead of load, T, equals load, T1, A 5/60 plus N. References